Today it's about how to handle interruptions on a Raspberry Pi. First, we will write a Python script to handle some interruptions from two switches, and I will talk a little bit about what not to do when handling multiple interruptions at the same time. Then we will code the same application in C++. And to finish, we will connect our Arduino to the Pi and check how fast the interruption can go until we start losing it. That's gonna be our stress test. So I put together this circuit, very simple. Just two switches, connect one to the pin 5 and the other one to pin 12. I did not add any pull-up or pull-down resistor. We will use an internal pull-up resistor from the Raspberry Pi. So let's start coding. Okay, so let's start open Genie. I will save this file and I will save this file as isr test.py. So the first thing that we want to do is import the libraries that we're going to use. So I'm going to import time, and I'm going to import the RPI GPIO. I'm going to rename it to GPIO only, just to make it easy. And then I'm going to create some global variables. And at first I would just create a counter for my pin 5 interruption, right? Then I'm going to create a function that's going to be my pin 5 handler, which is my callback function for every time the interruption happens on pin 5. And I'm going to bring my pin 5 counter inside this function. And now I'm going to just print something like pin 5 interruption happened, right? And the state of my pin is GPIO input 5, right? And my counter value is pin 5 counter. Okay, I also want to increment counter every time that I get inside this function. So far that's what I'm gonna do. So now let's make the GPIO configuration, right? So what I want to do first is set up my GPIO to BCM. So I want to always reference my GPIOs by the GPIO name, not the pin number. So I'm gonna say to my library that these numbers that I'm setting here, like GPIO input 5, it's the GPIO number, so I would say that's a BCM. And then I'm gonna GPIO setup. I'm gonna say my pin 5 needs to be an input. So the pin 5 needs to be an input, and I will set up a pull-up resistor internally because I didn't put any resistor on my board. So that's this line here. So with the pull up down parameter, and then I'm gonna add my callback function to that pin. So that's pin 5, and I want to call that function on both edges, so when the pin goes up and when pin goes down, and that's a pin 5 handler. Okay, that's all we have for the pin. I'm gonna just create a while loop here, so just to keep the code running, and that's it. Let's try to run this. So let's go back to the terminal, and I'm going to do Python 3 ISR test. Okay, so it seems to be running, so let's see. So every time that I press the switch, it sometimes generates more than one interruption, and that's normal because this is a switch, so it bounces a lot of times when you press one time, and that's actually expected to have multiple interruptions when you press a switch. But if you're really working with switches for your interruption, you don't want these multiple interruptions happening when you press a switch, right? So we have to implement what we call a debouncing, and the library has one. I'm going to show to you, and I'm going to also show to you why we don't use it. So if I put this parameter here, so bounce time equals 50, for example, 50 milliseconds, and I save this. Now I'm going to run the code again, and I just have one interruption every time that I press. But if you look at the state's not right. So sometimes the state changes, sometimes the state doesn't change correctly. So what I should see at the state is 0, 1, 0, 1, 0, 1. And sometimes it repeats itself. So I'm pressing multiple times here, it's not getting the right states. It's repeating the states. Right, so the best approach is implementing your own debounce. So let's do that pretty quick. So first I'm going to create a pin5 previous counter variable, and also going to create a pin5 time, initialize this with the time now. Then I'm going to bring these two new variables to my callback function, and I'm going to update here my pin5 time with the time now. Then I'm going to leave the print so we can see all the interruptions that are happening, but the debounce and the events for the button is going to be here. So debounce, and I'm going to do a if. So if my pin5 counter is different from my pin5 previous counter, and the time now minus the time that the last interruption happened is greater than 0.2. So then if this happens, I'm going to update my pin5 previous counter to value now, and I'm going to print, hey, we have a switch event, so do something with this value. And I'm going to actually say to you what this state is. But before test, let's also delete this, because we don't want the library now holding doing any debouncing, right? So let's delete this. Let's try this code here. Okay, so I have multiple interruptions happening, and then a switch event happened to 0, and then multiple interruptions, and then a switch event to 1, then a switch event to 0, switch event to 1, switch event to 0, bunch of interruptions, and switch event to 1. So now I have a more consistent event happening for my switch that I can use for any button that I have on my application. Now let's go back now. I'll just clear this. Let's go back and add the pin 12 now. So first I'm going to add the pin 12 as I did the first time that I was learning this, and I faced a very strange issue. So let me show you that. So what we're gonna do, we're gonna just replicate this for the pin 12. I'm gonna copy this function too. So I'm gonna create another callback function to pin 12, and I'm gonna show you that it's not really gonna work very well. So let's change all the 5s to 12. Hope it don't. Okay, so here my configuration. So I'm gonna change, I want pin 12 here, I want pin 12 here, and I want to execute my pin 12 handler. And then I don't want really any debouncing right now, so I'm gonna just comment this out because I don't want to show any switch events. So that looks good. Let's try it out. So save. Let's run again. So now I have pin 5, a bunch of pin 5. So I have pin 5 interruptions. Now pin 12. So I have pin 12 interruptions as expected. And we're gonna see here, I'm just pressing pin 12, and eventually I'm gonna see some pin 5 here we go. So I was pressing only the pin 12 and a pin 5 interruption happened. If I have some kind of encoder on my pin 5 and my counter increments by mistake because I'm handling interruptions for other pins, this is really a big problem. So see, another pin 5, and I'm just pressing here the 12. Here you go. It happened 2 times now. So we don't want this. This is bad, right? So what are we gonna do here is just handle the borders ourselves. So we don't want the library to handle the detection of the border, and we're gonna handle everything on a single callback function. And then we're gonna eliminate this problem. So what is important here is do your own border detection and handle everything on one single interruption. So I'm going to create 2 more variables to help us here. I'm going to create a prev state. I'm going to create here on pin 12 too, pin 12 prev state. I'm not going to handle everything in 2 callback functions. I'm going to handle everything in just one. So I'm going to copy this here. I'm going to put pin 5 prev state here, pin 12 prev state, and what I'm going to do is I'm going to create some local variables here called pin 5 state, and I'm going to read the pin 5 state, but also I'm going to read the pin 12 state at the same time, every time, no matter which interruption is actually triggered this callback function. I'm going to read all my inputs, okay? And then I'm going to do a if my pin 5 state is different from my pin 5 prev state, which means that I have a border, right? The state changed. So then I'm going to increment my counter, then I'm going to increment my time, and then I'm going to print something. And I also need to update my prev state. Here we go. Much better, right? So I'm going to delete this and do the same thing for the pin 12. So I'm going to just change here to pin 12. Pin 12. And this goes here. So now I have to change here too. So execute the same callback function for both, right? Okay, that's looks good. Let's try it out, save and run. So let's try pin 12 now. So I don't see anymore any pin 5. Let's try pin 5 now. So I don't see any pin 12 anymore, so I switch it to pin 12. No pin 5 interruptions anymore. Okay, so that's how we handle interruptions in Python. So let's start our C++ code and let's open Genie. And I will save this file as isr-test.cpp. isr-test.cpp. Okay, so the first thing that we're going to do is add some includes for our code. So I'm going to include stdio for my printfs. I'm going to include my time.h, and I'm going to include the GPIO library that we're going to use for the interruptions, which is onPi.h. And here I'm going to create two counters. One for the pin 5. I want an integer for that one. And I'm going to create another one for my pin 12. So pin 12 counter. And for now, I'm going to create two callback functions. And we're going to see a problem when we do that, and we're going to fix later. But to show you the problem, I'm going to first do it that way. So I'm going to do a callback function for pin 5 and another callback function for pin 12. So I'm going to do a void function. Void. Then I'm going to create a pin 5 ISR callback function. Right, and here I'm going to say that my pin 5 counter, I'm going to increment by 1. Okay, and then I'm going to print all the information about pin 5. So it's going to be pin 5, and then the status, right, and then the counter value, both integer. Okay, so for the status, it's I'm gonna just read input value for the pin 5, so digital read, and here is my pin 5, is my counter. Okay, so for pin 12, same thing, so I'm gonna call this, copy this, so you can change 5s for 12. Okay, now let's go for our main function. So let's create our main function, normal main function for C++, right, with the normal parameters. And let's say that the first thing that we're going to do is initialize the GPIO library. And to do that, I'm going to use one of the init functions that they have. They have a couple options. And I want to use the one that's called onPi setup GPIO, and that one will allow me to use the numbers 5 and 12 as a reference to my pin instead of the pin number of the pi. So this is my init, they call Broadcom pin number. Then I want to set up the pin mode. So I'm going to call the function pin mode, and I'm going to say that my pin 5, it's an input. And I'm going to do the same for pin 12. So my pin 12, it's an input. So I didn't put any resistor on my board, so we're going to add an internal resistor to my GPIO. So I'm going to do that with the bool up, down, control, and for the pin 5 I'm gonna add a pull up, and I want to do the same for pin 12. Oops. Pin 12. Next, I want to set up my callback functions to the pin. So I want to say wiring by ISR. I want to say that for the pin 5, I want to call the callback function for both edges, and I want pin 5 ISR callback function. And for pin 12, same thing. So I want for pin 12, I want both edges, and I want to call this function. So after all this setup, I can only do infinite loop here so my application doesn't quit. So let's do a delay here, and then I'm done. Okay, so now I know that Genie can compile and run this code, but actually I'm going to use a terminal. I think that it's good to know how to use the terminal to compile your code. So what I'm going to do here is just call g++ isrtest.cpp, which is my CPP file. And I'm going to turn all the warnings. I'm going to link my wiring pi library to my code. It's already installed when you installed the Pi, and then I want to generate my output as ISR test. Okay, so if I check here now, I have a ISR test in green here. So let's execute this. It seems to be running. Let's see. So pin 12, pin 5. So you can see that pin 12 generated a bunch of interruptions, and that's fine. It's a switch, so we know that a switch or a button can bounce and generate multiple interruptions. And if your application it's a switch or a button, you do need a debouncing. But first, I want to address an issue that also happened when we were doing Python, and it's something that I saw a lot of discussion on the internet. It's that when an interruption for one pin is happening, the interruption for another pin may also happen. And there's a lot of discussion and some people saying that's a best practice on how to do your hardware to avoid this. I prefer to fix that with software. So let me show the problem first. So we're gonna just click on pin 5, and what I'm looking here, it's a pin 12 interruption. So look at here. I'm just pressing the pin 5, and some pin 12 is happening. See, in my pin 12, it's on state 0. See, the 12 happens all the time. So if I put my 12 to 1, for example, then the 12 doesn't happen, or doesn't happen that often. See, only pin 5. So I'm pressing only 5. I see only 5. If I press the 12 now and change my pin state to 0, so now my pin 12 is 0, now the 12 happens all the time, even when I press only 5. So we don't want this behavior. This is bad. So what we're going to do is fix by software. So I'm going to just quit here and go back to the code. So what we're going to do is we're going to put everything in one callback, and no matter what interruption happened, we're going to check for the border ourselves. So we're not going to trust the border detection from the library. We're going to do ourselves. So first, let's create some variables to help us out here. So I'm going to create a pin 5 and last state, and I'm going to create a pin 12 last state. And then I'm gonna take this pin 5 here, and I'm gonna make just one function like this. And I'm gonna do like a pin 5 state. Oops, pin 5 state is equal to digital read of pin 5. So I get my pin 5 state. I'm also gonna get my pin 12 state, digital read 12, and I'm gonna check for the borders myself. And if the border change, if the pin state changed, then I'm gonna do something about it. So if my pin 5 last state is different from my pin 5 state, so what I'm gonna do, I'm gonna handle my pin 5 interruption. Okay, and I'm gonna also update my last state. So my last state will be equal my state. Okay, let's do the same thing for pin 12. Okay, that looks good. Now let's just change here so both pins are for the same callback function. And let's compile this and see how that works. So let's compile and run. Okay, let's try pressing pin 5. Now I don't see any pin 12. Let's change the state of the pin 12. Now pin 12 is 1. So that looks good. Actually, the pin 12 was showing up on pin 5 when pin 12 was 0. So I'm going to change it back to 0. And now I'm going to press pin 5 again. And I don't see any pin 12. So that's how I like to handle my interruptions. So just to summarize here, everything is one single function, and I check all the states every single time, no matter what interruption happened. Now let me show you how to do the debouncing for the pins in case you really want to use a switch or a button for your application. So first thing you have to do is add a new include, and I'm going to include the chrono. It's going to help us to get the timestamps for each interruption and control time. I'm also going to include here using namespace std to make the code a little bit easier. And then I'm going to create two new variables to help us out here. So I'm going to create int pin 5 last counter. That's going to tell us when the counter actually changes. And I'm going to do the debouncing only for pin 5s. And I'm going to do a chrono time point chrono system clock pin 5 time. That's going to hold the timestamp for the interruption. And then on my callback function, I'm gonna do that my pin 5 times, so it's chrono high resolution clock now. So that will give me the time of that interruption happened. So let's go down here on my delay. Now I was not doing anything, but now I need to. So what I'm going to do is get a timestamp of the time now. So I'm going to do auto time now. It's equal chrono high resolution clock now. So same thing that I did for my interruption. And then we're gonna do if my pin 5 counter is different from my pin 5 last counter. So what I'm gonna do. So what I wanna do here is calculate the difference between now and the last time my pin 5 interruption happened. So what I'm gonna do is create a variable called diff, and that's gonna be chrono duration cast. I'm gonna do a chrono milliseconds, and I'm gonna do the difference between now and my pin 5 time count. So that's how you calculate the difference between two timestamps. And then I'm gonna say that if my difference is greater than 50, so it's been a while since the last time an interruption happened, I'm gonna just process this interruption. I'm gonna generate a pin 5 event. So what I'm gonna do is just print pin 5 debounce event, and I want to show the state of my pin. Right, so I'm gonna do a digital read on my pin 5. That's my final state. And then I just want to update my last counter. Last counter is gonna be pin 5 pin 5 counter. Okay, close this. Now I want to change my delay to something like around 50 maybe. And let's compile this. Let's see how that works. And let's run. So let's generate some interruptions for pin 5. Okay, here it's a good example. So I had 3 interruptions and just one event, and that's exactly what I want for a debounce system. I think that's all for the C++ part. For the stress test, I connect an Arduino to pin 5 and 12, and I generate the same output for both. And it looks like this waveform, where we have 5 pulses that will generate 10 interruptions, and a rest time where I can read the count of interruptions and check if it's equal to 10. And then I repeat the pulses every second. What I'm changing here is the pulse time, making it smaller every test. I let it run each test for 3 hours, and these are the results. We can say that the Python code worked up to 1 millisecond pulse time or 500 Hz, with a very reasonable performance. But it's easy to see that the performance is way better in C++. When I tried a pulse time of 0.5 milliseconds, the Python code started to lose counts every second, not reliable at all. The C++ code worked very well up to 0.125 milliseconds pulse time, or 4 kHz, and I started losing counts every second with 8 kHz. I hope this table helps you to check if whatever you need to connect to the Pi is compatible or not. Thanks for watching.